Hi, I'm Gustav, 50 years old. In this lesson on the techniques and applications of definite integration, we are taking a look at this example over here. So this example, you have a double integration x dx dy, and d here is bounded by x minus 1 square plus y square is equal to 1, and x minus 2 square plus y square is equal to 1. First of all, we need to know what this graph looks like, alright? So, this graph, we have an x-axis and we have a y-axis. Alright, so first of all, x minus 1 square plus y square is equal to 1, which means it's a circle with radius at 1, 0 and with the center at 1, 0 and radius of 1. Alright, so let's just say here is its center. So you have something like this. And then x minus 2 square plus y square is equal to 1, which is a circle of radius 1 centered at 2, 0, which is here. Right, so you'll probably see something like this. And essentially, this is the region you will be having. Alright, so now that we know this is the kind of region you're looking at, we need to know what kind of boundaries you have. Since for integration, you need a 1-to-1 function. You can't just have multiple to 1, or in this case, pretty much 1-to-2 or 2-to-1, depends on however you like to integrate it, alright? So let's take a look at how we can change this up a little bit. Now we know the one on the left is x minus 1 square plus y square is equal to 1, while the one on the right is x minus 2 square plus y square is equal to 1. If you want to integrate with respect to x first, now how about let's just integrate with respect to x first. The left side of your circle on the right will be x is equal to, so since this is on the left, when you move your y square to the other side and square root on both sides, you will have 2 minus square root 1 minus y square. Or for your right side of your circle on the left, you're going to have x is equal to 1 plus square root 1 minus y square. Alright, so this is what we will have to look at. And of course, you will need to know what are your points of intersection. So, how about let's take a look at this point of intersection first, the one below. What is its x coordinate? Well, of course, it is directly between your two centers. And since its radius is 1, that means this is 3/2. And then you can just put 3/2 into whatever you have here. So let's say 3/2. So 3/2, that means 1/2 squared, which is 1/4. And 1/4, so y squared is equal to 3/4, which will give you square root 3/2. But you have to be aware which is negative, since this is below your x-axis. That means you have negative square root 3/2. Alright, so that means for your one above, it will be 3/2 square root 3/2. Right, so now that we know this information, let's start integrating. So, inside here, you'll still have x dx dy. Now y, where is y from? From x. Where is x from? Where is x to? So x, since it is from left to right, you're going to have 2 minus square root 1 minus y square until 1 plus square root 1 minus y square. And then for a range of y, which would be what we just calculated, negative square root 3/2 to square root 3/2. Alright, so that means we can integrate whatever we have for x first. So there will be half x squared, substitute in 2 minus square root 1 minus y squared to 1 plus square root 1 minus y squared, and then dy. So of course you would want to substitute in the values, which you will have 1 plus square root 1 minus y squared minus 2 minus square root 1 minus y squared. Right, so in the next step, we will have to expand the entire thing. So half integrate from negative square root 3 over 2 to square root 3 over 2. You're going to have 1 plus 2 square root 1 minus y squared plus 1 minus y squared minus 4 plus 4, 8. Is it? No, it's just 4. So plus 4 square root 1 minus y squared minus 1 plus y squared. So this is what you are going to have to solve. And of course we want to try to simplify a little bit before we start integrating. So 1 plus 1 minus 4 minus 1, which will give you a negative 3, plus 6 square root 1 minus y squared is basically all you're going to see. Now the first term, we can easily integrate it. But how about the second term? The second term, however, we will need to make a little substitution. So what kind of substitution, you might be wondering? Take a look at 1 minus y squared. What kind of substitution do you think we'll have to make? Well, of course, since it is 1 minus y squared, we would need either sine or cosine. Alright? So how about let's say we let y be sine theta. So dy is equal to cosine theta d theta. And your range for theta, since it is negative square root 3 over 2 to square root 3 over 2, what do you think will they be? So you're going to have negative pi over 3 to positive pi over 3, since you would prefer them to be within your principal domain and of course in the right order. Alright? So that is what you're going to have. So your first term is going to be negative 3 over 2 y, substitute in negative square root 3 over 2 and square root 3 over 2. And then for your second term, we'll just plus 3 integrate from negative square root 3 over 2 to square root 3 over 2. And then, make a substitution, so it is not the same, sorry about that. It is negative pi over 3 to pi over 3. And then, square root 1 minus sine square, which is cosine theta. We have another cosine theta from your dy to d theta, so cosine square d theta. And this is what you're going to have to solve. So the first term, if you just substitute in the values for y, you're going to have square root 3 over 2 plus square root 3 over 2, which is just multiplied by square root 3. So 3 square root 3 over 2. And then for your second term, you're going to have your double angle formula, which is 3 over 2 integrate negative pi over 3 to pi over 3, and 1 plus cosine 2 theta d theta. Alright, so this is what you're going to have to solve. Now the first term of this should be pretty simple. Actually the entire thing should be pretty simple, since you're going to have negative 3 square root 3 over 2 plus 3 over 2 theta, substituting the values negative pi over 3 and pi over 3. And then for a cosine 2 theta, you're just going to have to put in another half. another half, and cosine integration is sine, so plus 3 over 4 sine 2 theta, substituting the values negative pi over 3 to pi over 3. Alright, so you're going to have negative 3 square root 3 over 2. Then since that is pi over 3 plus pi over 3, which is 2 pi over 3, so this is just plus pi. Well, for your term behind, you're going to see sine 2 pi over 3, which is a positive sine pi over 3. So positive sine pi over 3 would just be your square root 3 over 2. So you have a positive square root 3 over 2. And then sine negative 2 pi over 3, which is in your third quadrant. So it'll be negative, but negative cancels out with the previous negative. So we're going to have, again, another square root 3 over 2. So that means it's just multiplied by square root 3, so plus 3 square root 3 over 4. So the final answer is pi minus 3 square root 3 over 4. Alright, so I hope for this question you're clear of it so far. Let's take a look at what kind of method we use. And in fact, this is just going to be method 1. Alright, so you may be wondering what other kind of methods there are, but you can first explore on your own, since we'll just explain more about this kind of question later. Alright, so this method 1, we're using Cartesian coordinates. Since if you see a circle, you can definitely think of polar coordinates, and if it's solvable in Cartesian coordinate, it should be solvable in polar coordinate. It will just be probably either easier or more difficult or tedious. Alright, so we took a look at what kind of region this is. We determine the different functions, we determine the different points, so we can get the range for your integration. And with this range for integration, then you can of course start integrating. While integrating halfway, we made a trigonometric substitution, and with this substitution we can then fully solve everything with another use of a double angle formula. Alright, so I hope for this question you're clear of it so far. I'll be ending this here, and thank you for your watching.